to keep my subscribers happy. All right. I had it ready to go here, and then I got sidetracked. Sorry. So here we go. A telephone pole is supported by 2 wires on either side. So they're on either side. That's important. It's not just on one side. Please read these carefully, because when I write them or when I get them off of, like I actually solve this first, make sure it makes sense, and then I might change the wording to make sure you get them in the right place. So on either side, there's 2 angles of elevation for each wire, which makes sense because we're going from the ground up, okay, respectively. So 35 for the first one, 60 for the second. The wires are anchored 15 feet apart. That's important. Assume the wires are connected at the same height. Also important, along the pole. Sketch the scenario, label all known parts. So you should be able to get a mark out of this one, hopefully. But the idea is this is the ground. This is the pole. We don't know how long the pole is. We just know they attach at the same height, right? So one is going to be 35, and one of them is going to have a 60. So technically, if you want to be accurate, one should be a little steeper. So this one should be the 60, and this should be the 35. And obviously, if this is a smaller number, you're further back. Think about it this way, right? Just pay attention to this one. As you look to the top of the building, the closer you get, the higher you're going to have to look, right? So your head is going to have to tilt up. So that's maybe going to help you. Does it really matter at the end of the day? No. But I do like to have a bit of a picture, a realistic picture, if at all possible, okay? So you've got that. And this is 15 feet here. Okay? 15 feet there, anchored. Okay, so you get a mark for that. If you have the 35, the 60, and the 15, you get a mark. I'm going to say this. If you made a mistake on here, it's a -1 right away, but then we're going to be forgiving later on as we do the other questions. Okay? Calculate the length of each wire. I'm going to do that here. How can I do that? For now, forget about this. Forget about the pole, right? We're just going to say, we can figure out this angle up here. I'm going to call this P for pole, right? Angle P there. So I'm going to figure out angle P. That's 180 minus 35 minus 60. Okay? And that would be 85 degrees. You get half a mark for this one. Okay? Half a mark for having that angle P solved. For some, you don't have to show the work. It just has to show up. So now I have a pair. This angle, watch this. It goes from this side to that side, which means it's going to span this whole bottom here. This angle corresponds to that one. So we're going to go sine of 85 over 15. And this is sine of, we got to be careful what we do here. I'm going to call this wire 1, wire 2, or some distinction. Give it letters, whatever you want. Just make sure you have distinctions there. So if you use 35, use this angle, you're going to find W2. That's what I need to see, that this is consistent. W2 is going to be found by multiplying and dividing. If you get that right, that's 8.64. So this is, you get a mark for coming up with this. I'll give you 1 mark today, so that's 1.5. Let's give this 1.5. It doesn't really matter. 1.5 for one answer. This is wire 2. Wire 1. I'm going to solve this here. I'm just saying, right? That would be, I'm using the same pair. Sine of 85, this one, over 15. And then it's sine of 60 over W1. W1 is 15 times sine of 60 divided by sine of 85. And wire 1 is 13.04 feet. We're going to give this Let's give this 1.5 as well. So 1.5, 1.5 for both answers and half for the angle. Can we change the angle to 1? I'm just going to make that easier today. 1. So that makes 1.5, 1.5, and 1 is 4, right? So we're going to change question B out of 4. So 1 mark for the graph, 1 mark for the missing angle, because this is really the key that unlocks everything else. Okay? So listen carefully here. I know some of you thought of this differently. So some of you probably say, oh, there's a 90 here. 90 and 60, that's 150. This must be 30, right? And then you went over to this side, and you're like, okay, 90, 35, this is 55, right? You still get an 85 out of it. At the end, if you add up this little bit and this little bit, you get 85. So it doesn't matter how you get there, you're good. What you cannot say, listen carefully to this one, you cannot say that sine of 55, right, corresponds with 15. That is a no-no. Same with 30 and 15, it doesn't work. So that's the problem if you use the little slivers. If you use 30, folks, you would only be able to find this stretch right here, okay? If you use 55, you'll be able to use this stretch right here, okay? Another thing I want you to refrain from doing is assuming the wires are the same length. That's not true. This is the main reason, right? This is 35, this is 60. They're two different angles. They're two different lengths of wires, okay? If these had been the same, then you had a point. If these two are the same, but they're not. Okay, so a few observations here. So that is B in a nutshell, right? B is right there, solving the two wires. C, determine the height at which the wires are connected on the pole. So basically the height of this triangle that we've created. This is what we want. You have two slants. You have this one and that one. You choose. If you use wire 1, you're going to go wire 1 times sine of 35. That'll get you there. That's the shortcut. Let's say you miss the shortcut altogether and you're like, well, let me cut out that triangle. Okay? I'm going to cut out that triangle here. This is the height I want. I have wire 1, which is 13.04. I have this angle, which is 35. You have a pair here, sine of 90 over 1304, sine of 35 over h. You're going to get the same answer. I'm just going to go with a shortcut here. Right? It's that side times sine of 35. H is 7.48 feet. Okay? So you get a mark for that one. If you use the other side, that would have been what? 8.64 times sine of 60, right? If you use this slant times sine of 60, you still get the same, I hope at least. It might be off by 0.01. That's okay. If that's the route you took, you get the full marks there. Okay, so this page is now worth 6. 6 marks for this page. And the back side is going to be probably where a lot of us had more difficulties, right? And that's okay. It's to be expected. Depression is a lot harder to deal with, right? Angles of depression. Backside. We're good? Okay. For now, just wait a little bit for now, Raver and Clark. I know you're discussing math. I love it. But for now, just till we're done this, okay? Mr. D hiked to his favorite spot while he was out on a scouting trip for upcoming hunting season. He's standing on top of a cliff overlooking a swamp. From the cliff, he spots some geese at an angle depression of 50. Okay, so that is important, right? So the geese are at this angle of depression. Okay. About 100 yards behind the geese, so 100 yards behind the geese, he notices some beavers, and they're at an angle depression of 30. Okay. Both are located to the right side of where he's standing. Sketch the scenario, label all unknown parts. So we're going to go with A. And this, you can go wrong really, really fast with the angles of depression, right? So this is Mr. D up here. This is like, assume this is the cliff, right? You're standing up on the cliff. Let's assume it's straight down here. It doesn't matter. But there are some geese that are spotted first, and 100 yards behind those geese, there are beavers or a beaver. So that's the scenario that you want to kind of, so the geese are at an angle depression of 50. You cannot put the 50 there because there's no horizontal here, right? You have to draw your imaginary horizontal. Okay, so this is 50. Okay, and it's gonna get a little messy now because 100 yards behind there's the beavers, and so you're looking at them as well. So that's cutting the 50 there. I don't know if you had that same problem, and that might be the reason why you sometimes have issues with this type of question. So maybe it's a good idea to get rid of the 50 there. Right, I'm going to get rid of it. And maybe I'll use a highlighter and I'll say, right, that this is 50 right here. This is 50 degrees for the orange. Okay. And then the 30 is for the beaver. So that's also here. That's just this one, this sliver right here. Okay. So that is the 30. I would say if you got this wrong, it's a -1 right away. Okay, if you got this concept wrong, you're going to be off. Okay, but if you have this, just this, without anything else filled in, you're doing okay. Show the parts that need to be determined. I haven't even asked you that yet, right? But you're going to do that soon enough. Okay, so it's kind of like you might have to go back to the diagram to fill it in with X's and Y's and Z's and whatever. Okay, another thing here, which is kind of right off the bat, you can bring this 50 down here. Okay, so I'm going to complete this. This is just me filling in the gap. Okay, there's a 50 here. This comes in here, alternate interior angles, right? The 30 comes down here, alternate interior angles. So angles are easy to fill in. This is a 90 here, we're assuming. And by the way, what's this little sliver here? It's 50 minus 30, right? So this would be 20 degrees. Because 30 and 20 make up 50. That's what we need, right? If this is 50, then this is what? This other side. 130, right? Because these are supplementary here. And let's check. 130 and 30, that's 160, correct? 160 and 20, 180. So we're good. And here, we could probably find this one here. I don't see the use of it yet, but you could figure out that one. But I think I'm good right now. I'm going to continue my journey now. I have at least one side, and I have a bunch of angles. You're actually good to go here. Like you can go to town and solve this one. Okay, so we'll say 2 marks for the graph. You be the judge here, but I would say if you got these wrong, the angles up here, it's -1 right away, right off the bat. Okay, what is it asking for? Calculate the direct distance between Mr. D and the geese. So we want this here. So this is X. Okay, that's the first unknown. That's what I mean by label the unknown parts. You might have to go back and do that. So, and if you want to tell yourself, right, side X, if you want to, that's optional. But let's figure that out. I want to use my space wisely. I'm going to do that here. What can I do? I could go sine of 20 over 100 and then sine of 30 over X. That's what I'm going to do. Hold it. Can you use cosine law? You need 3 sides, right? That's one candidate, not even close. The other one is side angle side. You need at least 2 sides and the angle wedged in between, right? You don't have that. So cosine law is like out of the question here. But we do have a pair. The 20 is with 100. So I'm going to go sine of 20 over 100. and then I'm going to go sine of 30 over x. Okay, that's my method. Anybody use this right triangle here? You can't, because you don't have a side here anywhere. So that right triangle is useless in this case. So we're going to go x is equal to 100. You may copy down as much as you want. Just use a marker or a pen, right? Divided by sine of 20. X is, oh, flip, sorry, 146.19. If you got this, you're good. So we're going to give you 2 marks for this. So 1 mark for setup, 1 mark for the correct final answer. I have to say this. If you made a mistake up here with your angles, obviously this is going to be different. Obviously. So you would still get the 2 marks here if you're using the information that you've come up with. So for example, if you put the 20 here, some students make this 20. Right there, alternate interior, boom, 20. This is not alternate interior to this one because it's touching these two. So if you put 20 here, then this will be 160 for you. But then you should have figured out that it won't add up, hopefully. But so you do get the 2 marks for this step if you have sine law and it jives with your graph. So that's the nice thing about these ones, as long as you're consistent. So B is done. C. Using cosine law, mean, right? That's a mean thing to do. Calculate the direct distance from Mr. D to the beavers. So we want Mr. D to beavers, direct distance, right? Straight. So it's not climbing down the cliff and then swimming or walking down the swamp, right? It's like direct. So we're going to do that here. I have to use cosine law. So I know x right now. This is 146.19. Let me just do this for you. I think some of you might need this, right? Distill it. Get rid of all the stuff you don't need. So I have side, angle, and I have this side here, which I know is 100. Okay, so I can solve for y here. So how does this go? Y squared is equal to 146.19 squared plus 100 squared. And then I'll give you a bonus later, which is going to be, if you use sine law and you come up with the same answer, of course I'm going to give you the marks. I'm not going to take marks away here today, okay? Because you know how to do it. That's the most important thing. But this is using cosine law. Y is going to be square root of this whole thing, which is going to be a big number. And you're ready for the big number? This is 37,625.28, and that keeps going. So no, sorry, I'm way off. I was writing down the wrong number, sorry. My bad. And obviously this will be different if you chose, if your graph is off, right? So y is 22398, and we are in yards here. This would be the distance from Mr. D to the beavers. So obviously if you have different values, then you're going to have a different answer here. If you use sine law and it's consistent, so how would sine law have worked here? I would have just gone sine of 20 over 100 and then sine of 130 over y. And voila, you got your y there. Okay, so that's okay. Full marks today because it's Monday. Okay, D, determine the height of the cliff Mr. D is standing on. I'm going to use side x and multiply by sine of 50, right? Because this is kind of facing, if I look at this right triangle, that's what I'm going to use. You could also use y times sine of 30, because then you're using this big right triangle here. It's up to you. So height is 146.19 times sine of 50. And so height is 111.99 yards. 1 mark for that one. Obviously, that'll be different for you if your graph is off, right? But if I see you doing this, you get the mark. So I usually go check, but then I go step, meaning you got the mark for the step, not for that number. The number is off. Is it asking something else? No. I could have asked you how far from the base of the cliff are the geese, or how far from the base of the cliff would the B versus B, right? Then you're solving either for this long side here or this one here. I could have asked for that. And then 3, did I scratch 3, or did I ask you to solve 3? I did ask you to solve for question 3, yeah. So we'll do that. XYZ has the following side length, sketch it, calculate the largest angle. So let's do that. I'm going to go like this. And Z, this is going to be, I don't really care what yours looks like, honestly. But this is X, this will be Z for me, because I want the 7-inch, the longest side to be there. I'll put the Y here. So Y is 5, X is 3. How about, we'll give you a mark for that. Be nice today. I think that is just part of solving it, but the largest angle is where across the longest side. So whatever you do, it's Z, across some side Z. So cosine of Z is plus minus. This side is 7 here. That's the most important, and square it. And then the others take up the rest of the spots. Like that. If you do the top, you get negative 15, and you get 30 in the denominator. And so angle Z is going to be found by going cosine inverse of that, which is negative 0.5. Emphasis on the negative. You usually want to emphasize the positive, right, in our lives, but not with cosine. So that's what you should be getting. And so 1 mark for that. So this back side is 2, 4, 6, and another one is 7, and 2 is 9. Doesn't matter how it went today. We're going to just improve from that point, okay? So it took me 22 minutes to correct it, right? It takes less if you solve, right? But, so back side is 9. The front was what, 6? 9 and 6, 15 total. Okay, so put at the top 15.